Okay, we got our second part of our review here. We'll begin by just taking the tension arrow and realizing that it has two components because it's at 19 degrees. Some of that tension is going to be directed horizontally. Some of that tension is going to be directed vertically. So you can see I've went through and I labeled each of these arrows, the 5 arrows, accordingly. That's the order that you need to do it in. I refer to it as going up the ladder. So you want to make sure that you understand that this has to be done in a certain order as 1, 2, 3, 4, and 5. If you don't do it in that order, you're not going to work out. Probably the first thing you should do is find the acceleration. So we use magic physics formula number 3. We eliminate d naught and we eliminate v naught, and we're left with this. Traveled 20 meters and it took 4 seconds. We need to square that, so it's actually 16. So we're going to have 28ths. So a equals 28. So 20 divided by 8 is 2.5. So that's the acceleration in the x direction. That's one of the things we need to find in order to find some of these different components. Now we can start going through our different numbers here. So we're going to take 50 times 9.8. That's going to give us my first force. 50 times 9.8. So we get 490. So that would be this arrow right here. Now remember, our shortcut for this would be just MA. The reason for that is sum of forces in the x equals FTX equals MA. So we can put in the mass 50 and multiply it times our acceleration 2.5 and we get 125 for this red arrow here. Once we solve for the x component, we can then use more trig to come up with the resultant or overall. So to do this, we have to take our answer for the red arrow, FTX, and divide it by the cosine of the angle. So we take 125 and we divide it by cosine of the 19, and we get 132. So that's the hypotenuse. The hypotenuse is 132.2. Once we have the hypotenuse, we can then sine that, so we can take the hypotenuse, which is FT, and we can multiply it times the sine of the angle, and that'll tell us our y component. So if we take our previous answer and we multiply by sine of 19 degrees, we end up with 43. So that's how much of the tension is directed up. So all we have to do if we want to find out what the force of normal is we take the weight 490 and subtract the amount of up or lifting up that we do, and the result is 447. So understand this is all due to Newton's third law. The ground's not going to push back any harder than it has to. It's equal and opposite. That's the big part of Newton's third law. So the summation would look something like this. Sum of forces in the y. You'd have the normal plus the FTY. Those two things together minus the weight equals 0. So even though it's an equilibrium in the y, normal and weight are not the same. This is a common misconception. You have to understand that if you lift up on it. In fact, if we pushed at a down angle, then the force of normal would be greater than the weight. So understand the y as well as don't just memorize it, understand the y. Alright, so there's another little bit of practice here for Q19.